Session 2.1 Trigonometric functions of acute angles. We have the white triangle here, and then we let A represent any acute angle in the standard position. We talked about it in the session 1.3 already. When you have the side A that will be equal to opposite over hypotenuse, which is going to be y over r. And then cosecant will be reciprocal of the side, so that will be r over y. Okay, I need you guys remember these 6 trigonometric functions. And if you don't remember, you could review the session 1.4, the video lecture. Cofunction identity. For any acute angle A, cofunction values of complementary angles are equal. Remember what is a complementary angles? Sum of the angles will be equal to 90 degrees. Okay, that's complementary angles. This is the cofunction identities. Okay, sine A equal to cosine 90 degree minus A. And cosine A, that will be equal to sine 90 degree minus A. Let me explain it here. Okay, we have the white triangle here. When we have the sine theta, okay, sine theta, that will be equal to opposite over adjacent. So that will be A over C. Okay, right? Now, how about if I want to find cosine alpha? Cosine alpha, that will be equal to adjacent over hypotenuse, A over C. Okay, remember that sum of the angles inside a triangle, that will be equal to 180 degrees. So you know that alpha plus theta plus 90 degrees is going to be equal to 180. Okay, when we subtract 90 for both sides, alpha plus theta equal to 90 degrees. So what is alpha equal to? Alpha will be equal to 90 degrees minus theta. Okay? So we're going to plug in alpha equal to 90 minus theta. So we will have a cosine 90 degree minus theta equal to A over C. And then A over C equal to A over C. So therefore, sine theta equal to cosine 90 minus theta. Okay, this is why we have the cofunction identity. Sine A equal to cosine 90 minus A here. That's the same idea with the cosine. You could do the same thing and then you're going to get the same identity. And how about tangent and cotangent? Okay, same idea for the tangent. I will have tangent theta equal to opposite over adjacent. Okay, and then when we have a tangent alpha, that will be B over A. Okay, tangent alpha, I could be equal to 1 over cotangent, right? Reciprocal, equal to B over A. And then cotangent alpha, that will be equal to A over B. That will be same idea with these two guys. Okay, right? And then tangent theta will be equal to this guy, cotangent alpha. Okay, and then we know that alpha, that is equal to 90 degree minus theta. Okay, that's why we do have the second cofunction identities. Tangent A equal to cotangent 90 degree minus A. It also applies for the secant and cosecant. Okay, this is the proof for the cofunction identities. Okay, example 1. Writing functions in terms of cofunction. We just look at the cofunction identities. Write each function in terms of its cofunctions. So cosine 52 degree. Cosine, you're going to change to the sine, right? So it's equal to sine 90 minus 52. Do the math. That will be equal to sine 38 degree. I want you guys try to do B and C. Okay, tangent. The cofunction will be cotangent, right? So that will be equal to cotangent 90 minus 71. Do the math. Cotangent 90 degree. And then last one, secant will be equal to cosecant. Cosecant 90 degrees minus 24. That's equal to cosecant 66 degree. Example 2. Find one solution of the equation. Assume all angles involved are acute angles. Acute angles means that will be less than 90 degree. A. Cosine theta plus 4 degree equal to sine 3 theta plus 2 degree. So you know sine and cosine are cofunction. So the equation is true if the sum of the angle is going to be 90 degree. Okay, so we could add up these two guys. That would be equal to 90 degrees. The ideas is similar to this one. When you do 52 plus 38, that will be equal to 90 degrees. Okay. Now we're going to combine the 9 terms. Theta plus 3 theta. And then 4 degree plus 2 degree. And we subtract 6 for both sides. Divided by 4 for both sides. You're going to get 21 degree. Okay, B. Do the same thing. So they are cofunction identities. So when you add it up, that's going to be equal to 90 degree. Combine the 9 terms. Divided by 3. So theta will be equal to 30 degree. Increasing or decreasing functions. Has A increased, Y increase, and X decrease since R is fixed? So you could look at the pictures here. When angle A is increasing, okay, the angle become bigger. Then the Y is gonna be increasing also. Okay? And the R is always fixed. So the changes will gonna be the X, right? When Y is increased, X will be decreased. Okay, look at the sine A. Sine A is equal to Y over R. Okay, R will be fixed. So when Y is increasing, sine A is also increasing. Cosecant A will be equal to R over Y. So when Y is increasing, cosecant A will be decreasing. Okay, it's going to be opposite, these two guys. Okay, cosine. When X is decreasing, cosine A is also decreasing when the R is fixed. Secant. When X is decreasing, secant A will be increasing. Okay, last one, tangent. When Y is increasing, but X is decreasing at the same time. Okay, a large numerator and a smaller denominator result in the value of tangent A is increasing. Okay, so tangent A is increasing also. Cotangent. So when x is decreasing, y is increasing. So cotangent A is going to be decreasing. Determine whether each statement is true or false. Sine 21 degree is greater than sine 80 degree. So we only look at the angle. 21 is going to be greater than 18. When 21 is increasing, sine 21 is also increasing. So this is true. Okay, B, secant 56 degree less than or equal to secant 49 degree. Secant theta is equal to r over x. When x is increasing, secant theta will be increasing. So it should be opposite. So this one should be false. (30°, 60° triangle. Bisect one angle of an equilateral triangle to create two 30 and 60 triangles. So equilateral triangles, talking about all these three angles are 60°. Since they do have the same degree, so they do have the equal length of these three sides. Now I'm gonna cut it half. So I'm gonna get two 30, 60 white triangle. Okay, one angle is gonna be 90 here. Okay, so same thing, you do have a 2 and 2 here. I do have a 2 and 2. Once I cut it half, each side here gonna be 1. Okay, and then I'm gonna let the x in here. Now we're gonna use the Pythagorean theorem to solve for the x. Remember, a squared plus b squared equal to c squared. Okay, we just look at this triangle. So we have 1 square plus x squared equal to 2 squared. Okay, we're gonna solve for it. So x squared, that will be equal to square root of 3. Okay, so now I will have this 30-60 triangle. This is a white triangle. And then I want you guys try to find the 6 trigonometric function values for a 60-degree angle. Remember sine 60 will be opposite over hypotenuse. So that will be square root 3 over 2. Cosine 60, that will be adjacent over hypotenuse. Okay, tangent 60 will be opposite over adjacent. So that will be square root of 3. Now I want you guys try to find cosecant, secant, and the cotangent. Okay, check your work. Cotangent is going to be 1 over square root of 3. And then rationalize times square root 3 over square root 3, which is going to be square root 3 over 3. Secant, that will be 2 over 1, which is going to be equal to 2. Cosecant, that will be 2 over square root of 3. So rationalize, we're going to times root 3 over root 3. Okay. Okay, another white triangle, 45 and 45. So 90 degree, this is a 45 and 45. And this is an isosceles triangle. So when they do have the same equal measure here, the side is going to be equal length, right? So you have a 1 and 1. We're going to have the R here. So use the Pythagorean theorem to find the R. So R equal to square root of 2. Okay. Okay, do the same thing. Find the sixth trigonometric function. Sine 45, that will be equal to 1 over square root 2. Rationalize, so that will be rect 2 over 2. Cosine, same thing, right? Tangent, that will be equal to 1. Okay, now find the rest of the trigonometric functions. Cotangent is also equal to 1. Secant, that will be rect 2. Cosecant, that will be also the rect 2. Okay. Okay, so we summarize, and for the trigonometric functions, I need you guys remember these two special triangle, 30, 60 and 45, 45. Okay, and also I need you guys remember all the sign here. There's a 1, 2 square root 3, 45, 45 with 1, 1 square root of 2. Okay, there's some special angles. You guys need to know how to find cosine, sine, tangent, cotangent, secant, or cosecant without using the calculator. On the exam, when I ask you guys what is a sine 30, you're gonna tell me that would be 1/2. I want you guys write it in the fraction, not the decimals. Okay, one more time, that's some special angles you guys need to remember in a trigonometry. Like you do have a 30, 45, 60, actually like 90, 180, 270, 360. You also need to know what sine, cosine, tangent, cotangent, secant, cosecant without using the calculator. So I highly recommend you guys can memorize these two triangles. Okay, when I ask for the sine 30, so you could look at this triangle. Sine 30 will be opposite over hypotenuse. That will be 1/2. Okay, when I ask for tangent 45, so it's going to be opposite over adjacent, which is going to be equal to 1. Okay, that's it.